Given you a handout, and so basically if you look up at that upper paragraph, it says, now that you have learned about pi and the formula for circumference, you can solve many real-world problems involving circles. The example in your book shows the solution to a problem related to the novel Around the World in 80 Days by Jules Verne. Read this example carefully, then read the examples below. We're just going to go ahead and start with that first example. And so if you notice, it says the wheel on Devon's unicycle has a diameter of 27 inches. Okay, so that's a diameter. How far will the unicycle travel in 100 revolutions of the wheel? Give your answer to the nearest whole foot. So basically, what we need to do is we need to figure out how far the wheel travels in one revolution. And then do what? Multiply that by 100. So to find one revolution, that is the circumference. So in this case, the circumference is pi times the diameter, which in this case will be pi times 27. What does that come out to be? 27 times pi?
Oh, 84.
What is it? 85 point what? It's 84.85. Okay, so that is one revolution. What I'm going to do is there are 100 of those revolutions. So I'm going to take that times 100. And so when I do that, that's when I should get 8,485. Now this will be inches, right? What did they ask you to find? Feet. So if that's inches, how do I convert that to feet? Divide by 12. And so how many feet will that be? 707 feet. So that's the first answer, folks. Questions on that? Did you ask?
Yes.
Okay. Now let's look at the next one. It says Devon rides his unicycle 2 miles to school each day. About how many revolutions does the wheel make during his trip? So how do you think we should do that? Let's think. 2 miles would be how many feet? 10,560 feet, right? That would equal my 2 miles. Now I want to figure out how many revolutions is 10,560. So what am I going to do? Right, so I need to find out how many feet one revolution is. I know one revolution is 84.85 inches, right? So one revolution is 84.85 inches. How many feet would that be? 7.07, right?
Yeah.
So that is one revolution. What are you going to do with the 10,560 and the 7.07 feet? Divide the two. So you're going to take 10,560 divided by your 7.07, and that will give you how many revolutions you have. 1,494 revolutions. Did somebody else get that? Okay. So you're going to have to use a lot of problem-solving skills on these problems. Okay? They're not going to be ones that are going to be done right away. Okay. 1 through 5, section 6. An audio CD spins at a rate of 200 rotations per minute. If the radius of a CD is 6 centimeters. How far does a point on the outer edge travel during the playing of a 57-minute CD? So what we're going to do is we're going to figure out how far it travels in one revolution. So how far it travels in one revolution would be the circumference, right? And the circumference, in this case, I'm going to use 2 pi r, since I know that r is 6. So what would the circumference of that be? 12 pi, which is, thank you, 37.7 centimeters. So that is one revolution, folks. Okay, so in 1 minute, how many revolutions will it do? It'll do 200 revolutions. So I'm going to take 37.7 times 200, which is what? 7,540. Okay, so that is how many, or how far it travels in 1 minute. Well, I want to know 57 minutes. So what am I going to take with that then? Right. I'm going to take my 7,540 that I just found, and I'm going to take it times 57, which is what?
425,000.
Questions? Now, obviously, each problem is going to be different, and you're going to have to adapt based on what you're given. Let's look at one more. The city of Rutledge wants to build a circular walking track that is a 1/4 mile long. So it's in a circle, okay, not an oval. To keep vehicles off the track, the city plans to build a fence around the track. The fenced area will be square, and the fence at its closest point will be 5 feet from the edge of the circular track. How many feet of fencing will be needed? So on yours, there should be a diagram. Okay, we've got our circular track. And very rarely they don't ever build circular tracks. They always build them oval because circular will in fact cause some problems. Okay, and so what you notice here, okay, is that we have the diameter of that circle, and then we have 5 feet on either side. This will also be 5 feet since it is a square. Okay, those just aren't marked. Now what they're doing is they're asking us to figure out how much fencing I need. So basically I need to find the diameter, right? And they tell me that the circle needs to have a circumference of what? The circumference needs to be a 1/4 mile. Well, if you notice, they want fencing in terms of feet, right? Okay. Well, I know that 1 mile is 5,280 feet. So how much would a 1/4 mile be? What? Okay, so 1,340 feet would be the circumference. 20, sorry. So we'll erase that and we'll put a 2 there. Okay, so 1,320 feet is what the circumference must be. Well, I know the circumference formula. Circumference formula is pi times the diameter, right? So pi, circumference equals pi times the diameter. Well, how can I find the diameter now, folks? Divide by pi. So what is 1320 divided by the pi button on your calculator? Should be something in the 400s. 420.17 will be our diameter. So if that's 420.17, what will the side of the square be? The side of this fence? Yeah. 430.17. And if it's a square, what do you know about all the sides? All the sides are the same. So each side needs to be 430.17. And actually, they want to the nearest foot. So let's just go with 430 feet. So I know that each side needs to be 430 feet. Okay? So what's the total amount of fencing I'm going to need? 1,720 feet. Okay? So questions? Your assignment is not very long, but I'm going to warn you, it's not the easiest thing in the world. Okay, so if you have questions, please ask. It's on page 342, 1 through 5. Tomorrow you will turn in both section 6.5 and 6.6. Your chapter 6 exam will be probably Wednesday of next week, maybe Thursday.